So we've got a graph of g of x. We want to sketch and label the image after a vertical compression by a factor of 1/3, then a translation 2 up. So what that's going to look like is we're going to take these 4 points from our original graph. So our original graph has -5, 3, -2, -3, 1, 0, and 4, 6. Now, we'll always, in our first arrow, do all of our stretches and compressions. We have a vertical compression by a factor of 1/3. That will mean that your y values are going to get multiplied by 1/3. And then we're going to move it 2 up. We'll do that in our second set of arrows. So we're always doing stretches / compressions first, and then translations second. So the only stretch compression that we have affects our y values. So all of our x values are going to stay the same. And our y values are multiplied by 1/3. So if you're going to make mistakes, you're going to make little arithmetic errors here. You're going to multiply wrong or add wrong. So when you get your final graph, you always want to do a check to see, does it seem like it's the right shape in the end? Finally, 2 up, again, that will not affect any of our x values, but we'll add 2 to each of our y values. And now we can sketch this graph. So, -5, 3. That point ended up staying exactly the same. -2, 1, 1, 2, and 4, 4. Connect your graph. The equation of our new graph. So in this graph, I've got my points off to the side. I wouldn't need to, it's not bad if I decided I'm going to label these points because that's 4, 4. It's not bad to label them. But in this case, because there's a scale given on this graph with your x and your y, it's obvious that this point is 4, 4 because the scale's already given. So then you wouldn't need to label it extra if you didn't want to, because the scale has already been given. If I wanted to state the equation of this graph in terms of g, how do I write a vertical compression by 1/3? That 1/3 would be outside of the function and in front of it. There's nothing affecting x, so we'll just have g of x. There will be nothing inside of the function where the x is. And up to happens afterwards. So there we have the graph. If we want to imagine it, a compression by 1/3 would squish it towards the x-axis, and then the +2 moves it up 2. So we ask ourselves, does our final graph look like it's been squished and then moved up 2? Yes. Okay, the questions we can do are 4, 5, and 6, but I do want to point out something with the example that's actually in the textbook as well. So just look to the side at example 1. So here's the graph of f of x. We want to sketch and label the image after a horizontal compression by a factor of 1/2. and then a translation 3 units to the left. So we've got our original points. Again, we can label all 4 of them. We've got -4, 3, 0, -2, 2, 5, and 4, 2. Our first set of arrows is always our stretches and compressions. In this case, we want a horizontal compression by 1/2, so we're multiplying x by 1/2. And then, translation second, we're going to move this one 3 to the left. So if we're multiplying our x values by 1/2, our y values aren't going to change. X by 1/2, this will become -2. This stays at 0. This will become 1, and this will become 2. And finally, 3 to the left. Again, our y values won't change. And if you subtract 3 off of each of those x coordinates, those become our final points. So far this has been identical to the vertical one as far as doing the points. And as far as drawing it goes, we can plug these points in. We have -2, 3. We've got 0, -2. Oh, sorry, I'm graphing the wrong points. -5, 3. We've got -3, -2. We've got -2, 5. And we've got -1, 2. Connect your points. And look, does it look like it's been squished? The horizontal compression is squishing it towards the y-axis. And then we're going to be moving this one 3 to the left. And our final graph does look like that's what's happened to it. Now, the reason I wanted to do this one as well is when writing this, a question comes up. Should this be written like this? So our function is f of x. Should we write it like this? X by 1/2 means we're going to have a 2, right? And then 3 to the left means we're going to have an x plus 3. Or should it be written like this? Okay, so far they're identical, right? There's nothing different. Should it be written like this with an extra set of brackets? Both of those have a 2 multiplied, and both of those have a plus 3. Only one of those is the right equation. Because if I multiply this out, right, if I distribute that 2, can you see that I get 2x plus 6? And that's not the same as 2x plus 3. So these both look the same, well, look similar, but they're not the same. But both seem to say multiply x by 1/2 and move something 3 to the left. How many people, I'm just going to do a little survey. Go with your gut. I'm not going to tell you, I'm going to tell you afterwards which one's right and which one's wrong. If this is your gut feeling on the right, you raise your right hand. If this is your gut feeling on the left, you raise your left hand. Everybody should have a hand up in the air. Okay, some people are like touchdown. Okay, a little half mix, half and half. It is the correct way is this way. Now, we're going to write a special note at the bottom of this page. So even title it Special Note. When you have a horizontal stretch / compression slash reflection, any one of those, with a horizontal translation. You must write it in factored form. We are going to refer to this over and over and over again, because you're going to be so tempted when you see equation like this one written on the left, y equals f of 2x plus 3. I'm going to ask you, what's going to happen there? You're going to say, multiply x by half. I'm going to say, good. Then you're going to say, go 3 to the left. This one isn't 3 to the left. This one is actually 1.5 to the left, not 3 to the left, because you would have to rewrite this and factor out the 2. And if I factored out the 2, I'd be left with x plus, well, 2 times what is 3? Is 1.5, or 3 over 2. So that one's only going to go 1.5 to the left. But you are going to say over and over again 3 to the left. That's going to be something that is going to be hard to remember. I once had a student, and of everything that I said that was hard to remember, she had something on her phone that sent a reminder. And every night at 10 p.m., her math reminders came through. So one of her math reminders was this one, horizontal stretch. Every night at 10, it came up on her phone and reminded her about that. By the end of the year, she was like getting reminders for like half an hour. Probably wasn't reading them and just put her phone down because it was annoying. I'm not sure. But this will be something I'm going to refer to over and over again, because you are going to forget this. But it comes up a lot. And it's an easy place for you to lose marks, because you're going to be tempted to say in this first one that it goes 3 to the left, but it actually only goes 1.5 to the left. In order for it to go 3 to the left, it has to be in the factored form. If we look back to the example that we did at the beginning of class, notice that they had it in factored form. The 2 is factored out, and then the x plus 3 was in brackets. So that one was correct for us to say that it went 3 to the left. Okay. At the bottom of the page, or sorry, on the next page, you have all of this information, which tells you to do your stretches and then your translations. Again, we can shorten all this. If you always work from left to right, you will always do your stretches and compressions first, and then your translations. And then it will work out fine. And if you do point by point like we did, you do not need to remember this very awkward looking formula thing, because you will do it naturally when you work left to right. But if that, for whatever reason, is easy for you to remember, maybe it's the name of your uncle, I'm not sure, then go with that. But I would suggest that working from left to right is going to be a lot easier.